Again, this doesn't require very much in terms of protein engineering, so this is something we could carry out on very, very large scale. And so the application for this that we have in mind is for biofuels, and I'll just get to introduce this topic in light of the time. But the idea is that there are a number of different approaches to making biofuels through fermentation processes, ethanol being probably the most familiar, but many up-and-coming methods to make butanol, isopentanol, all kinds of other alcohols and structures require all kinds of different fermentation techniques and often synthetic biology. But what we want to do is improve the upstream of this process, that normally the glucose that feeds these organisms come from starch, from corn. What we'd like to do instead is use lignocellulosic biomass, cellulose being the most abundant form of carbon in the biosphere. If we can use that as a building block, it is estimated to be an almost inexhaustible supply to feed into these fermentation processes. The problem is that cellulose is very difficult to degrade. There are actually very few organisms that can do it, and the ones that do have that ability have a series of very interesting enzymes. They're collectively called cellulases, or endo and exoglucanases. These cellulases come in and both deconstruct the crystalline regions of the cellulose, thus splitting apart the strands, and they also come in here and chew these amorphous regions as well, chewing this into ever smaller pieces, providing then ultimately glucose units that can be used for fermentation. So it's estimated right now that the cellulase cost, the cost of these enzymes, are the key economic barrier that prevents this process from being feasible. It depends on what numbers you work with, but it's only by a factor of a few, like say a factor of 2 or 3 or 4 is the problem in terms of the economics. And so what we thought is maybe we could use our chemical reactions to make these recyclable. Thus, you could carry the cellulase enzymes through a couple rounds of processing. And so the idea was that we would use bioconjugation at the N-terminus of a cellulase. This is something we could carry out on a very large scale, and we could attach these to polymers. And this would be a nice soluble